Welcome to This Explainer. Today, we're unlocking the fascinating science behind human movement. I mean, think about it for a second. Going from a wobbly, clumsy toddler to a fully coordinated adult. That requires an absolute masterclass in biomechanics and biological timing. So, we're going to build a comprehensive map together of exactly how we grow, mature, and ultimately learn to move through the world with confidence. Okay, let's dive into this. Have you ever wondered why, by the time high school rolls around, some kids absolutely thrive in gym class, while others just completely dread it? It's a pretty striking contrast, right? And it perfectly frames the fundamental question of our explainer today. Because the truth is, we all start out with the exact same basic movement building blocks when we're young. But somewhere along the line, our experiences vastly diverge. So what actually causes this physical divide? Is it strict genetics? Is it environmental exposure? Or is there a much more complex biological timing mechanism at play here? Well, here is our roadmap to figure that out. First, we'll define the main concepts. Then, we'll look at critical periods and readiness, stages of childhood growth, gender differences in stature, and finally, achieving physical literacy. Starting right off with Section 1, defining the main concepts. Before we can really unpack human development, we need to stock our kinesiology toolkit with three foundational terms. The first concept is growth. Now, in the context of kinesiology, growth is highly specific. It refers strictly to a measurable change in body size, quantity, or functioning. Just think of this as the raw physical expansion of the body. Getting taller, gaining mass, expanding your lung capacity. It's the quantitative stuff we can easily plot on a chart. Let's move to and see how this builds into our second concept, which is maturation. If growth is about size, maturation is really about progress toward the biological finish line. It's the extent to which a physical characteristic resembles a mature biological state. So two kids might be the exact same height, meaning their growth in that exact moment is identical, but one might be way further along in their internal biological maturation process than the other. And finally, we have motor development. This is the study of how our motor behaviors change over time, and it happens because of a dynamic dance between our biology and our environment. It's exactly where our physical growth and maturation collide with the outside world, like learning to throw a baseball or ride a two-wheeler. Moving on to Section 2, critical periods and readiness. Because as it turns out, athletic ability isn't just about what you're born with. Timing is literally everything. This brings us to what we call critical periods. These are highly specific windows where a child's nervous system is incredibly plastic and sensitive to environmental stimuli. During these brief windows, exposing a kid to certain movements results in the absolute optimal development of physical and cognitive skills. Interestingly enough, for a lot of skills, this window opens very, very early in a child's life. But the real-world challenge for parents and educators is trying to align activities perfectly with these rapidly closing biological windows. So, the crucial point is understanding readiness. Readiness means an individual is physically prepared to acquire a skill, but equally important, they have the internal motivation to actually learn it. If the biological maturation is there, but that internal drive just isn't, the development won't be smooth. You simply cannot force a skill during a critical period if the child isn't truly ready. On to Section 3, stages of childhood growth. Let's map out the actual chronological stages of development. Here is a quick map of childhood growth. From ages 1 to 6, early childhood, we see slower, much more constant growth, which is accompanied by major improvements in coordination. Then, from ages 7 to 10, mid-childhood, kids often experience a growth spurt, which, fascinatingly enough, is preceded by an accumulation of fat. Essentially, the body storing up the massive energy reserves required to fuel that upcoming bone and muscle growth. Finally, ages 10 to 13, late childhood, brings the major height spurt, the start of reproductive maturation, and a total redistribution of body weight. Now, take a mental snapshot of that timeline, because here is the absolute key takeaway. While we all generally pass through that exact same sequence of infancy to childhood to adolescence, there is considerable variation. Not everyone grows as fast, as much, or in the exact same way as the person standing right next to them. And this natural biological variation, it's the literal root cause of that gym class divide we discussed at the very beginning. This leads right into Section 4, gender differences in stature. Let's look at how variations in stature diverge as kids approach their teenage years. Now, what's really interesting about this comparison is just how dramatic the biological divergence really is. In late childhood and adolescence, boys typically increase lean body mass and decrease body fat. They mature a little later and hit their maximal standing height around age 18, meaning they reach their athletic potential in some sports quite a bit later. Girls, on the other hand, tend to increase body fat during this phase. They mature earlier, often between 12 and 13, and reach their maximal standing height much sooner, usually around age 16. I mean, imagine putting a group of 13-year-olds in a gym class together. Biologically speaking, they are on completely different planets. And finally, Section 5, Achieving Physical Literacy. How do we take all this science and achieve our ultimate goal? And this brilliantly illustrates that our ultimate goal isn't just structured, rigid exercise. It's about playing, moving freely, and adapting to our environment. The whole point of understanding kinesiology isn't just to help someone pass a physical fitness test. It's about integrating a really wide range of movement capacities into a healthy, vibrant, long-term lifestyle. We call this overarching goal physical literacy. And why does physical literacy matter? Well, because it goes far, far beyond just participating in a sport or checking a box to say you're fit. It is the absolute bedrock of overall health and well-being. You see, a physically literate individual doesn't just know how to run on a treadmill, they move with competence and, most importantly, with confidence across a wide variety of activities and environments throughout their entire lifespan. Which brings us to our final thought for this explainer. Knowing what we now know, that our critical periods, our readiness levels, and our maturation timelines are vastly different, how do we radically rethink and design physical education? How do we ensure that we aren't just catering to the early bloomers, but rather fostering lifelong physical literacy, competence, and a genuine joy in movement for absolutely everyone? It's a massive challenge, for sure, but understanding the science of kinesiology is the very first step to making it happen. Thanks so much for joining me for this explainer, and keep learning.